Welcome back, my friends. Here we go. The last two items that we're gonna test, and we're actually gonna have us write down both of the items because I want you to be thinking about the last one. Okay. This next one we're gonna test is a blue paperclip. And underline the word blue. It's a blue paperclip. And then the last thing we're going to test is a pencil. So those are the two things I want you to be thinking about. And you're welcome to try and make a prediction on both of them right now. So you would write, on the blue paperclip whether you think that's a conductor or insulator. And then you'd write the same thing by the pencil, what you think that is. Okay, I left the two most difficult ones for the end just to see if you could maybe accept this challenge. So, right, your guess for blue paperclip. I guess I should maybe show it to you, right? Here is the blue paperclip. So as you can see, it's the same size as the other paperclip, but it is blue. Okay, let's make sure that our circuit is working. I'll come and do it this way this time. So I've got the batteries touching, hopefully the light's on. There we go. So I got a working circuit. You ready? I'm going to test the blue paperclip. Do you think that electricity is going to go through this blue paperclip like it did the other paperclip and light up the light bulb? Let's see if you're correct. 3, 2, 1. What? It's not going through this time. Wait a minute, let me try the other paperclip. Here's the other paperclip. Let's try it. Ah! The other paperclip worked. Why doesn't the blue one work? Let's try it again. Nope. Doesn't work. The blue paperclip is an insulator. What? Can you think about that and maybe explain that? That's a little confusing, right? Well, if you know anything about these different paper clips, this is metal. This is actually also metal. Listen to them drop. They're both metal. But this blue paper clip is covered in a thin layer of what's called latex, right? A thin layer. It's kind of like balloons are also made out of latex, where like it's a really thin rubbery plastic material. And this paperclip is this exact paperclip, but covered in that blue color, probably just for design, or like people choose to want colorful paperclips. I don't know. But it has this like thin layer of plastic or rubber. In fact, I'm going to try and show you. I don't know if it's going to be too blurry or not, but I'm going to show you that I kind of keep trying not to show you this silver part. I've been holding it like that because I've scratched it off every time I've done these science experiments with other classes. I've scratched it off to show you can remove the latex layer of this, and it actually will still work if you remove the blue part of it and you just get down to the metal part. So let me just show that to you. Let's make sure our circuit works. See, I'm so glad I test that every time. It drives me crazy that I move things accidentally. Still, no working circuit just by itself. Okay, now it's working. So I'm going to test. So here's the blue part again. If I attach it to the blue part and touch it with the blue part, nothing. Nothing happens to the light bulb. But if I attach it to the silver part that was under the blue and then touch the silver part, ta-da! It goes through. It kind of does a little more like, can you see that it's like lighting up, but it's like getting, like it goes in and out. The light goes in and out. So it's not quite as strong as like the penny, right? So let me just pick up the penny. I mean, that one's like boom, and it doesn't really waver. So the blue paperclip is an insulator. I just wanted to show you why it was an insulator. Even though it's made out of metal too, it has a blue covering around it that's made out of thin, rubbery plastic. And those are insulators. So the blue paperclip was an insulator. I'm guessing that I actually tricked maybe a few of you on that one. And that's okay too. That helps your brain think things through a little bit better. So nice job. Okay, here's the last one. A pencil. And I'm just like, we're using one of Miss Fisher's like favorite type of pencils, right? These are the pencils I always use. This is the item. So maybe think through what you think is going to happen when I attach the alligator clip to this. Make your prediction, whether you think it's a conductor or insulator. circuit ready. We're going to test it. Get that paper clip out of here. You can see that I have a third battery for later, but hopefully we get time to do that. I'm going to make sure my circuit's still working and strong. Yep, it is. All right, what do you think about this? What do you think about this pencil? I hope at home you're like dying to answer and wanting to like shout out the answer, right? I bet you might be having a question right now too. In fact, this question comes up a lot. Like, well, what part are you going to connect? Because you just saw what happened with the blue paper clip. And depending on which parts I connected, made a difference. So, pencils are made out of, they've got a rubber eraser. The outside of this particular pencil is plastic. Oh, the whole outside is. And then if I click it, it's lead. So it does depend on which part of the pencil I'm going to attach it to. Okay, so let's try attaching it. Don't put your answer yet down right here, but let's try attaching it at the eraser level. Let's see what happens. You should know what's going to happen because remember, erasers, I should double check that it's working still. Sorry, I bumped that thing. Okay, it's working. So I'm going to attach the eraser and then touch it with the eraser. Nothing. So if I attach the pencil on the eraser level, it doesn't light up. What if I attach it to this plasticky part of the pencil? And then I touch the plasticky part. See that little yellow tricky? Will it go through? Nope, not going through. Should we just test that our circuit still works? I think that's always a good idea. Still works. So both of these ways didn't work. The eraser didn't work. The plastic part didn't work. But what if I try attaching it to this lead? What do you think is going to happen then? It's a little scary. It's probably going to break the lead because it's so strong, the clip is, but let's try it. Okay, I attached it to the lead. I'm going to attach the lead to the light bulb. Whoa, did you see that? Ooh, it's pretty cool. I'm touching the lead barely to it. And you can see that it's like pretty dull, but it's still lighting up. So is the pencil a conductor because it lit up right here with the lead? Is it an insulator because of this plastic part or because of the eraser? Think about that for a minute. And I actually stumped all of you. Dun, dun, dun. A pencil is neither a conductor nor an insulator. It is a resistor. So, everyone got that wrong. So don't think you can get 100%. What I want you to do is the actual test results right here. You can miss that one totally fine. It's a resistor. And it's a resistor because a piece of lead, especially in like, I should bring a normal pencil. A lot of you like the ones that you have to sharpen. In one of those pencils, a piece of lead runs all the way through it, right? Up until the eraser part. And this kind of is the same. Lead runs all the way through here. So you've got this conductor piece that runs all the way through it, but then it's wrapped in this insulated shell. And that's kind of what these wires are. Inside of them is this really thin layer of metal. And what is lead? It's a type of metal. That's why you should never like draw on yourself with pencil or accidentally poke your finger with the pencil because that could cause lead poisoning because lead is a type of metal. It's like scratching the surface of your skin with metal. It's not a good idea. So a pencil is a resistor. Oh, I just love tricking you so much. Okay. Now we're going to finish the rest of this and we're going to see why Miss Fisher has this third battery for later. But let's quickly answer the rest of these. So, materials that allow electricity to flow through them easily. They can be thin. We saw some of them were thin. Thick. They can be thin or thick, it doesn't matter. They can be small or large, etc. There's lots of different types of conductors, as we saw. Something like a gum wrapper and a penny or a little teeny paper clip, right? Those were all conductors. Well, would a giant metal, like let's think about a basketball hoop, the poles that hold up a basketball hoop. Is that a conductor, the metal pole? Absolutely. It's a lot bigger of a conductor, but it still would be a conductor. So let's add to this next one on insulator. Materials that do not allow electricity to flow through them easily. They can be all sorts of sizes. We're just saying this in a different way than what we said the other one in. They can be all sorts of sizes. Okay, so the bottom two questions, I'm going to give you the main three things that would make good conductors, okay? The first thing that makes a good conductor is if it's anything that is metal. Anything made of metal is going to be the number one conductor. The next item is going to be water. Water is a really good conductor. Electricity flows through that so quickly. That's how people can get like electrocuted and things like that. So water. And then the third thing is humans, and I already mentioned that earlier. But those are the three main conductors: metal, water, and humans. And we wrote that in our electricity folder, but that's just a good review. I'm going to tell you just a quick little story. When I was in 5th grade, my mom let me get my very first pet. It was a little tiny, my teacher had a class pet in 5th grade, and it was a gerbil, and the gerbil had babies. And so she let kids get the gerbils as like prizes. And so I got one of them and we brought him home, and my mom was like, oh, great. Which I'm sure that's been the same thing for you sometimes. So we went and got, this gerbil was like teeny tiny. It was like this little black little gerbil. And I wasn't super great with animals, so it was like a big deal to me to try and take care of one. So I was so worried that this little gerbil was going to get cold at night, because I got him in like the winter. And so I got this like heated rock. You usually buy heated rocks for like iguanas or turtles, like reptiles. And a gerbil's not a reptile. A gerbil's a mammal. But so I got this like heated rock, and I plugged it in and put it in its cage, and I just thought it was the cutest little gerbil ever. And it was so little that it couldn't even drink out of like the water thing that you put on the side of the cage yet. I had to like feed it with a syringe. If you know what a syringe is, it's like how little babies take medicine, like cough medicine. You pull up and it fills the little tube up. Anyway, so you had to feed the little gerbil with that. You had to give him water because it was too little to drink out of the water tank. So I'm not even joking. I've only had the gerbil for like 3 days. Remember, I'm 11 years old, your age. And I get up in the morning and I'm like, I'm going to give the gerbil some water. I had named the gerbil Max. Yeah, you're welcome for that, Max. And so I got up and I was giving Max some water. And he was standing on, this is such a terrible story. I cannot believe I'm telling you this. He was standing on the heated rock, and he had like his little paws up. Like he was standing on his hind legs and like basically standing instead of on all fours. He was standing on his back legs and had his little paws up in the air and like holding onto the syringe. Like it was so cute, his little teeny tiny hands. And he was on the heated rock. Well, so where the cord from the heated rock was he was standing right by it, and some of the water from the syringe dropped into that area, like by the cord and on the heated rock. And I'm not even joking you, my gerbil stepped in the water, he stepped in the water, and he was on the cord at the same time, and it electrocuted the gerbil. It shook a little and then fell over and legit died. So in 5th grade, because of that electricity, and because even though he's not a human, he has blood running inside of him, and he's a mammal, and so he was a conductor. Plus, there was the metal through the wires. Plus, the water had fallen on the metal, and so he was touching the water and the metal at the same time. And I guess the electricity going into the rock helped complete this little circuit, and it was heartbreaking. That's right, I electrocuted my gerbil in 5th grade. Poor Max. Ugh, I'm so sorry that you had to hear that story, but I miss telling you random stuff, so enjoy. Really quickly to end this little science lesson. So 3 main conductors: metal, water, humans, or gerbils, you know. Okay, what are some materials that make good insulators? Well, as we saw, anything that was rubber didn't work. The erasers definitely did not work. And that thin layer of rubber over the paperclip didn't work either. Another main insulator would be anything that is wood. So anything that's rubber, anything that's wood. And then the third thing is anything that's plastic. So all of the things that we did today fit under these things. It was either something metal. I didn't use water because that's really dangerous. And ever since my little gerbil Max, I don't really want to test it with something like that. Anything that's human, right? I could have completed the circuit and told you I would refuse to do that. And then and then you have the rubber, wood, and plastic that are insulators. So that's pretty cool.